This video is going to be about statistical representations. So let's get started. The first representation that we are going to talk about are histograms. A histogram is used only for continuous data. So a reminder that continuous data are grouped together. So here you see the categories are from 10 to 15, 15 to 20, etc. What's special about histograms is that the y-axis is always going to be the frequency. So we see that in this class interval from 10 to 15, we have a frequency of 20. So 20 individuals fall in the category from 10 to 15. Another thing we notice about histograms is that the columns are touching. The reason why the columns are touching is because with continuous data, we don't have a break from 10 to 15. We already skip from 15.00001 to 20. So there's actually no gaps between them. A histogram is very different from a bar graph. A bar graph is going to be a graph in which there is a space between our lines, and bar graphs are going to be used only for discrete data. So if you have discrete data, you're going to be using a bar graph. That just doesn't happen as often in the IB. We see histograms more often. Our next focus for today is going to be talking about our box and whisker plot. So the box and whisker plot has 5 main important numbers that need to be identified. So let's talk about the box first. So the box, in the middle of it, we're going to have a line which represents the median. Remember, the median is our middle value, which we talked about last lesson. On either side of the median, we're going to have what's called our lower quartile and our upper quartile. Now, these are points that are also given to us from our calculator. So the same steps we did last class with our graphing calculators to find the one variable statistics, our calculator gives us Q1 and Q3. And then to finish up the whiskers, we have our minimum and our maximum values. Now, right now, the box and whisker plot you have seems symmetric. So there seems to be the same distance between maximum Q3, Q3 median, median Q1, and Q1 and minimum. However, this is not always the case. What is always the case is that 25% of all the data is in each of our sections. So 25% of the data is from the minimum to Q1, another 25% from Q1 to median, and so on and so forth. The last piece of information that we have is what is called the interquartile range. Now, this is a special type of range, so a special type of measure of spread, and it's going to be the size of our box. So the interquartile range is the Q3 minus the Q1 value. When we talk about box and whisker plots, we're often going to talk about outliers. Now, there's a way to mathematically calculate if a data point is an outlier or not. The equation is given to you in the formula booklet. So the equation is 1.5 times our interquartile range. So remembering interquartile range is the Q3 minus the Q1. And 1.5 times the interquartile range. This is going to give us a number. And if we are this number away from Q1 or this number away from Q3, then we are going to be considered an outlier. And this is going to make a little bit more sense in the example that we're going to do next. So keep in mind 1.5 times the interquartile range. This is a number which we're going to be away from Q3 and away from Q1. Okay, let's look at our example. A manufacturer claims to provide approximately 100 pills of particular medicine in each bottle, but some customers have complained that their bottles aren't filled correctly. To test the quality of their bottle fillers, they counted the number of pills from a sample of 200 bottles and recorded their findings in the table. Draw the correct box and whisker plot representing this data. Okay, the first thing that we're going to be doing with this data is we're going to be putting it into our calculators. And notice that we have data points from 92 all the way to 108, and we have our frequency list. So a reminder of how to start. In your calculator, you're going to go and click Stats, edit your list. You're going to delete the list that you have. So delete, and you're going to go delete the next one. And now I'm going to encourage you to pause the video and enter the data that you see. Once you have your data, you're going to go and run a one variable statistics. So you're going to go back on stats, calculate one variable. Our list is in L1 and our frequency is in L2. So we're going to go ahead and calculate that. Now we're going to scroll all the way to the bottom. The most important numbers that we have are our final five numbers here. Okay, every time you're doing a box and whisker plot from data, I want you to consider only the Q1, median, and Q3 given to you by your calculator. So only the Q1, the median, and the Q3 is what we are going to be using. So I have these written down on our slides. I'm going to get out of the stats page by going second function, quit. And now we're going to calculate for our outlier. Now, for our outlier is going to be 1.5 times the interquartile range. Now, the interquartile range is 102 minus 99. So I'm going to go ahead and do this calculation. I get the number 4.5. Now, this is the maximum number I can be away from Q1 and from Q3. So let me think about what's the maximum number I can be away from Q1 to start with. So what I'm going to do is I'm going to take the Q1 value and I'm going to subtract the 4.5. Any data point which is less than 94.5 is going to be considered an outlier. So any data point less than 94.5 is considered an outlier. Let's see if we have any outliers. From our data, we have 92, which is actually considered an outlier because it's less than 94.5. So that means that 92 is going to be an outlier. I'm going to put it on my number line, but it's going to be a dot and not included in my box and whisker plot. That means that my next minimum value is going to be 96. 96 is going to be the minimum of my box and whisker plot. Now let's look at if there's an outlier on the other side. So on the other side, we're going to have our Q3, 102, this time plus our 1.5 times the interquartile range, which is 4.5. And now we have the value 106.5. That means I cannot have a value bigger than 106.5. So let's go and see if we have any outliers. And in fact, we do. We have 108, which is bigger than 106.5. So 108 is going to be an outlier, while 106 is going to be considered our minimum value. So what does that look like when you create a box and whisker plot? You should always take into consideration your box and whisker plot needs to be on a number line. So you first place a number line going from 92 to 108. So 92 all the way to 108, your scale needs to be constant. We're going to put the two outliers that we've identified, we're going to put them as dots. And then the next smallest number was 96, so that becomes our minimum value. And then our maximum value is 106. So that's minimum, maximum. Q1, medium, and Q3 is unchanged all the time. Whatever our calculator gave us, that is the correct Q1, medium, and Q3. So we see 99, 100, and 102. Now that we know a little bit about our box and whisker plot and how it's created, we're going to talk about when you're looking at a box and whisker plot, if we know if it's skewed. What does skewed mean? It means it's leaning towards one side or the other. So the first image you have on the left is a box and whisker plot, which is very symmetrical. So this is what we would describe as a symmetrical box and whisker plot because our median is in the middle of all of our data points. So notice that the median is exactly kind of halfway between 10 and 20. Our median is at 15. And the box has the same length on both sides, same as the whiskers, same length on both sides. So this is an example of a symmetrical box and whisker plot. And if you would be drawing the bar graph that associates this data, you would have a symmetrical bar graph. The next one at the bottom is what we would call negatively skewed because most of the data points are at the back end of the data. So most of our data points are the bigger numbers. So negatively skewed, you'll see that the box is more concentrated towards higher values in numbers. The median is no longer in the middle between 9 and 1. It's closer towards the 9, closer towards the bigger numbers. So this is negatively skewed. And then positively skewed is the other way around. So most of our numbers are concentrated towards the smaller numbers, and we're going to have a median which is closer to our smaller number. These are important to realize because they're going to help us describe data. So when we see a box and whisker plot that's positively skewed, well, we're going to know that the vast majority of our data points will be at the front end of our data. Now let's do an example together. Let's look at this following parallel box plots and compare the students' time in grade 9 and in grade 12 that they spend on homework. The top one is grade 9, the bottom one is grade 12, and they're situated on a number line which is in minutes. And they're asking us to complete the following table. Now, I encourage you right now to pause the video and try this example by yourself and then come back to the video. For grade 9, our minimum is where we have our start of our whisker. Now notice here the scale. Between 0 and 30, there's 1, 2, 3, 4, 5 sections. So 30 divided by 5 is 6. So that means that we're going to be skipping 6 each time we go one of these ticks. So my minimum is actually 6. And then from here we have our median, which is 30, our Q1, which is 30, our median, which is 45, Q3 60, and our maximum seems to be 72. We do the same thing for grade 12. Grade 12, we're starting at 36, then our Q1 is 60, our median seems to be 96, actually 94, let me change that. And our Q3 is 96, and 105 is our maximum here. The range. Now the range, as we learned last class, is one number. So it's the maximum minus the minimum. So for grade 9, our range is 72 minus 6. So 66 is the range. For grade 12, our range is 105 minus 36. So 69 is the range. Interquartile range is Q3 minus Q1. So make sure you do that subtraction. For grade 9, it's 30. And for grade 12, it's 66. Sorry about my grade 10 here. I'm going to change that. Okay, next up. Determine whether the following statements are true or false, or if there is enough information to tell. The first statement, on average, Year 12 students spend about twice as much time on homework than grade 9 students do. Now for this statement, they're telling us on average. Box and whisker plots do not give us any information about average. The only information we have is minimum, Q1, medium, Q3, and maximum. So for this one, we do not have enough information to talk about what happens on average. Second observation, over 25% of grade 9 students spend less time on homework than all the grade 12 students. Okay, 25% of grade 9s. Well, each of these sections here represents 25% of grade 9. We notice that from the minimum all the way to Q1 until 30, this represents 25% of grade 9s. And it is true that 25% of them do spend less time on homework than all of the grade 12s. So for this statement, it is true.